Chapter 9 Differential Equations. Let us learn about homogeneous functions. A function f of xy is said to be a homogeneous function of degree n if f of lambda x lambda y is equal to lambda raised to n f of xy for any non-zero constant lambda. For example, consider this function which is y square plus 2xy. We will find f of lambda x lambda y, which is lambda square y square plus 2 lambda x times lambda y. We get lambda square times y square plus 2xy, which is lambda square f of xy. So, this is a homogeneous function of degree 2. Let us see another example. A function of xy sin x plus sin y. F of lambda x lambda y will be sin of lambda x plus sin of lambda y. We are not able to write it in the form lambda power n times f of xy. Therefore, this is not a homogeneous function. Now, let us see what is a homogeneous differential equation. A differential equation dy by dx is equal to f of x comma y is said to be homogeneous if f of xy is a homogeneous function of degree 0. That is, f of lambda x lambda y should be lambda power 0 times f of xy. For example, let us consider this differential equation dy by dx equal to x square plus y square divided by x square plus xy. If dy by dx is a rational expression, easily we can make out that it is homogeneous. Degree of each and every term is the same, 2, 2, 2, 1 plus 1 is 2. So, for a rational expression, if degree of each and every term is the same, then it has to be a homogeneous equation. Homo means same. Or we can check using this lambda method. Let us take dy by dx as f of xy. We will find f of lambda x lambda y. We get lambda square x square plus lambda square y square over lambda square x square plus lambda x times lambda y. Lambda square times x square plus y square divided by lambda square times x square plus xy, which is f of x comma y. So, it is of degree 0. So, dy by dx is a homogeneous function of degree 0. Therefore, the given differential equation is a homogeneous differential equation. Let us consider another example. Dy by dx equal to y cos of y by x plus x divided by x cos y by x. Let us take this as f of xy. We will find f of lambda x lambda y, lambda y cos of lambda y upon lambda x plus lambda x divided by lambda x times cos of lambda y by lambda x. We can take lambda out and we can cancel. We get the given function dy by dx, which is f of xy. Therefore, this is a homogeneous differential equation because f of xy is a homogeneous function of degree 0. We have two types of homogeneous differential equation. The first type is dy by dx, which is a function of y by x. To solve such equations, we first substitute y is equal to Vx, that is, we take y by x as v. Now, differentiating both sides with respect to x, we get dy by dx is equal to product rule, v into differential of x with respect to x is 1 plus x times dv by dx. The second type of differential equation is dx by dy, which is a function of x by y. In this case, we substitute x by y as v, that is x is equal to vy, and here differentiation has to be done with respect to y. Dx by dy is equal to, using product rule, we get v into differential of y with respect to y is 1 plus y into dv by dy. Exercise 9.5. In each of the exercises 1 to 10, show that the given differential equation is homogeneous and solve each of them. The first one, x square plus xy times dy is equal to x square plus y square times dx. Let us write dy by dx. In this question, we have to show that it is a homogeneous differential equation. We will take this function as f of xy. We will find f of lambda x lambda y, lambda square x square plus lambda square y square divided by lambda square x square plus lambda x lambda y. Lambda square is common. So, f of xy is a homogeneous function of degree 0. This is equal to f of xy. Therefore, the given equation is homogeneous. And we have to solve this. Dy by dx is x square plus y square upon x square plus xy. We substitute y by x as v, that is y is equal to vx, differentiating with respect to x. Dy by dx is v plus x times dv by dx. Therefore, this equation becomes v plus x dv by dx, which is dy by dx, equal to x square plus, substitute y as vx, v square x square divided by x square plus x times vx. No more y in the equation. We have substituted for dy by dx as well as for y. Now, the equation will be only in terms of v and x. X dv by dx is equal to, x square is common, and let us take this v to the other side, taking LCM, 1 plus v square, distribute that negative sign, minus v square. Therefore, the function is 1 minus v upon 1 plus v. We will separate the variables. 1 plus v upon 1 minus v dv. Bring all the v terms to this side because dv is on the left hand side, equal to dx over x. Now, on the left hand side, degrees of v are same. So, we will use long division method, or since the denominator has 1 minus v, we will write the numerator also as a function of 1 minus v. If I write minus of 1 minus v, I need 2 here. Open the brackets, we get 1 plus v, and the denominator is 1 minus v dv, equal to integral dx upon x. We will split the function. 2 divided by 1 minus v dv minus 1 minus v divided by 1 minus v, which is 1 dv, equal to integral dx over x. We get 2 times log of absolute value of 1 minus v. Do not forget to divide by the coefficient of v, which is minus 1, minus integral of 1 with respect to v is v, and integral of 1 by x is log of absolute value of x plus c. We will substitute for v, which is y divided by x, minus 2 log of absolute value of 1 minus y divided by x minus y divided by x equal to log of absolute value of x plus c. Minus y by x minus c is equal to log of x plus 2 times log of, taking LCM x, x minus y upon x. We will take this 2 as the power and combine these two terms. Log of log a plus log b is log a into b. Log of absolute value of x times x minus y the whole square divided by x square. This can be given as the answer. In the textbook, the answer is given by removing the logarithmic function. To remove this log function, we will raise both the sides to e. E raised to minus y by x minus c is equal to e raised to log. E and log are inverse functions, they cancel each other. We get x minus y the whole square over x. X minus y the whole square is x times e raised to minus y by x times e raised to minus c. X minus y the whole square equal to e raised to minus c is a constant. I can write it as some other constant a times x e power minus y by x. Question number 2. Y dashed is equal to x plus y upon x. We have to show that it is a homogeneous differential equation. We will take this as f of xy. Let us find f of lambda x lambda y. Lambda x plus lambda y upon lambda x. Lambda gets cancelled. We get f of xy. Therefore, f of xy is a homogeneous function of degree 0. Therefore, the differential equation is homogeneous. Dy by dx is x plus y upon x. We will substitute y as vx. Differentiating both sides with respect to x, we get dy by dx equal to v plus x dv by dx using product rule. Let us substitute for dy by dx and for y. Dy by dx is v plus x dv by dx equal to x plus y is vx upon x. We can cancel x. X dv by dx is 1 plus v and minus v, taking the left hand side v to the other side. After this substitution, it becomes a variable separable equation. dv is dx over x. Integrating both sides, we get v equal to log of absolute value of x plus c. We will substitute for v. Y divided by x is log of absolute value of x plus c. Therefore, y is x log of absolute value of x plus xc. Question number 3. X minus y times dy minus of x plus y times dx is 0. X minus y times dy is x plus y times dx. Therefore, dy by dx is x plus y divided by x minus y. Look at the degree of each and every term. It is 1. Therefore, it is homogeneous. We will show this by lambda method. We will take dy by dx as f of x comma y. We will find f of lambda x lambda y. It is lambda x plus lambda y divided by lambda x minus lambda y. Lambda is common. It gets cancelled, equal to f of x comma y. Therefore, the given equation is a homogeneous differential equation. Now, let us solve this equation. dy by dx is x plus y upon x minus y. We will substitute y as Vx, differentiating both sides with respect to x. We get v plus x dv by dx. dy by dx is v plus x dv by dx, and x plus Vx divided by x minus Vx. X is common. We will take v term to the other side. We will take LCM. 1 plus v minus v minus of minus plus v square. We get 1 plus v square divided by 1 minus v. Now, after this simplification, it becomes a variable separable case. Let us take v terms to the left hand side. 1 minus v upon 1 plus v square dv is equal to dx upon x. Now, the left hand side is a linear function divided by quadratic function, and there is no v term in the denominator. So, directly we will split this into two functions, 1 divided by 1 plus v square dv minus integral v divided by 1 plus v square dv equal to integral dx divided by x. Now, to integrate the second one, we will substitute the denominator as t. 2v dv is dt. The substitution is only for the second integral. The first term is integral 1 divided by 1 plus v square dv, and the second integral we have to substitute. V dv is dt divided by 2 divided by 1 plus v square is t, and the other side is integral dx divided by x. We will integrate. Integral of 1 divided by 1 plus v square is tan inverse of v minus half into log of absolute value of t equal to log of absolute value of x plus c. We will substitute for t. T is 1 plus v square, which is a positive number, so no need to write the absolute value sign. We will substitute for v now. Tan inverse of y by x minus half log of 1 plus y square divided by x square equal to log of absolute value of x plus c. Therefore, tan inverse of y by x is log absolute value of x. We are taking this log term to the other side, plus half of log of, taking LCM x square, we get x square plus y square and plus c. To combine these two log terms, we need half here, so we will raise it to 2. Therefore, half and 2 will get cancelled. Combining these two log terms, we get half log of x square times x square plus y square divided by x square plus c. Therefore, the answer is tan inverse of y divided by x equal to half log of x square plus y square plus c. Question number 4. X square minus y square times dx plus 2xy dy equal to 0. If dy by dx is a rational function, then we can solve it by taking dy by dx or dx by dy. 2xy dy is equal to minus of x square minus y square dx. Therefore, dy by dx is y square minus x square after distributing the negative sign divided by 2xy. We will take this as f of xy. We have to show that it is a homogeneous differential equation. Let us find f of lambda x lambda y, which is lambda square y square minus lambda square x square divided by 2 times lambda x times lambda y. Lambda square gets cancelled throughout. We get f of xy. Therefore, the given differential equation is homogeneous. Now we have to solve this equation. Dy by dx is y square minus x square divided by 2xy. We will substitute y as vx, differentiating both sides with respect to x. Dy by dx is, using product rule, we get v plus x dv by dx. Let us substitute. Dy by dx is v plus x dv by dx equal to y is vx. So, v square x square minus x square upon 2x vx. We can take x square common. Cancel x square. Let us take this v term to the other side. We will take LCM. 2v, the numerator is v square minus 1 minus 2v square, which is minus 1 minus v square divided by 2v. We will take minus sign out. 1 plus v square over 2v. Now we will separate the variables. 2v upon 1 plus v square dv is minus dx upon x. We will integrate both sides. This left hand side is easy. We will substitute 1 plus v square as t. 2v dv is dt. I missed n in the sentence, the given differential equation is homogeneous. Integral 2v dv is dt divided by 1 plus v square is t equal to minus integral dx divided by x. Integrating both sides, we get log of absolute value of t equal to minus log of absolute value of x plus, since these two terms are having log function, we will write the constant of integration as log of absolute value of c. Let us substitute for t. T is 1 plus v square, and here we will combine these two log terms. We get log of absolute value of c by x, because log a minus log b is log of a by b. Now to remove this log function, we will raise both sides to e. E and log will get cancelled. We get 1 plus v square is equal to c over x. Let us substitute for v. V is y by x, so we get v square as y square upon x square equal to c upon x. Taking LCM, therefore, the answer is x square plus y square is equal to cx. Question number 5. X square dy by dx equal to x square minus 2y square plus xy. Dy by dx is x square minus 2y square plus xy divided by x square. Dy by dx is a rational function. Look at the degree of each term, it is 2. Therefore, it is homogeneous, but we will use lambda method. We will take this function as f of xy. Let us find f of lambda x lambda y. Lambda square x square minus 2 lambda square y square plus lambda square xy divided by lambda square x square. Lambda square is common. We get f of xy. Therefore, The given differential equation is homogeneous. Now we will solve this equation. Dy by dx is x square minus 2y square plus xy upon x square. We will substitute y equals vx. I have told you rational expression questions we can solve by y is equal to vx method or x is equal to vy method. Let us differentiate with respect to x. Dy by dx is v into 1 plus x into dv by dx. Dy by dx is v plus x dv by dx equal to x square minus 2, y is vx, so v square x square plus x times vx divided by x square. X square is common. Let us take this left hand side v to the other side. They get cancelled. Now after this simplification, variable separable method, dv divided by 1 minus 2v square is dx by x. We will integrate both sides. We will write this as dv divided by 1 minus root 2v the whole square. And we will use the formula 1 divided by a square minus x square dx, which is 1 by 2a log of x plus a divided by x minus a plus c. We get 1 by 2a, a is 1, log of absolute value of root 2v plus 1 divided by root 2v minus 1. We may write this formula as a plus x by a minus x also, because of absolute value sign it does not matter. And we have to divide by the coefficient of v. Do not forget this, equal to log of absolute value of x plus c. Here the coefficient is 1 by 2 root 2, that is why we are not writing log c there. We will substitute for v. 1 by 2 root 2 log of absolute value of root 2 y by x plus 1 divided by root 2 y by x minus 1 equal to log of absolute value of x plus c. 1 by 2 root 2 log of, taking LCM, root 2 y plus x divided by root 2 y minus x equal to log of absolute value of x plus c. Because of absolute value sign, even if you write x minus root 2 y, it is the same. Question 6. X dy minus y dx equal to root of x square plus y square dx. X dy is root of x square plus y square plus y dx. Dx is common. We will write dy by dx. This is root of x square plus y square plus y divided by x. We will take this as f of xy and we have to show that it is a homogeneous differential equation. We will find f of lambda x lambda y. Root of lambda square x square plus lambda square y square plus lambda y divided by lambda x. We can take lambda square out. Lambda times root of x square plus y square plus y divided by lambda x, which is f of xy. Therefore, the given differential equation is homogeneous. Now we will solve this equation. Dy by dx is root of x square plus y square plus y upon x. We will substitute y as Vx. Differentiating with respect to x, dy by dx is using product rule, v plus x dv by dx. Dy by dx is v plus x dv by dx equal to root of x square plus y is Vx divided by x. We can take out x square, it becomes x, 1 plus v square plus v divided by x. Therefore, x dv by dx is root of 1 plus v square plus v and minus v. Now separate the variables. Dv divided by root of 1 plus v square is dx divided by x. We will integrate both sides. For the left hand side we have direct formula. Integral 1 divided by root of a square plus x square dx is log of absolute value of x plus root of a square plus x square plus c. Using this formula, the left hand side becomes log of absolute value of v plus root of 1 plus v square equal to log of absolute value of x. These two terms are having log function. We will write the constant of integration as log c. We will combine these two log terms. Now to cancel log function, we will raise both the sides to e. V plus root of 1 plus v square is cx. V is y by x. We will substitute. Y by x plus LCM is x square, and here the denominator x square becomes x, root of x square is x. X is the LCM. Y plus root of x square plus y square is equal to cx. Y plus root of x square plus y square is c times x square. Question 7. X cos of y by x plus y sin of y by x times y dx equal to y sin of y by x minus x cos of y by x times x dy. This is the function of y by x. If you have trigonometric function, it should be a function of y by x or x by y. Then only it becomes a homogeneous function. If you have only sin x or cos x, it does not become a homogeneous equation. Since it is a function of y by x, we will write dy by dx. Dy by dx is x cos of y by x plus y sin of y by x times y divided by y sin of y by x minus x cos of y by x times x. We have to show that it is homogeneous. We will take this as f of x y and we will find f of lambda x lambda y. Lambda x cos of lambda y upon lambda x plus lambda y sin of lambda y upon lambda x times lambda y divided by lambda y sin of lambda y divided by lambda x minus lambda x cos of lambda y divided by lambda x times lambda x. We can take lambda out. Here also lambda is getting cancelled. Which is same as f of x comma y. Therefore, the given differential equation is homogeneous. We will solve this equation. Dy by dx is x cos of y by x plus y sin of y by x times y. Don't forget to write these terms which are outside the bracket, divided by y sin of y by x minus x cos of y by x times x. We will substitute y as Vx, differentiating both sides with respect to x, we get this. Therefore, it becomes v plus x dv by dx equal to x cos of y by x is v plus y is Vx, sin of y by x is v times y is Vx divided by y is Vx, sin of y by x becomes v minus x times cos v times x. We can take x out, cos v plus v sin v times v divided by x times v sin v minus cos v. We will take this v term to the other side. We will have minus v. We will take LCM. V sin v minus cos v. We get, there is one v outside, don't forget this v. So, it becomes v cos v plus v square sin v, and let us distribute this negative sign, minus v square sin v minus of minus plus v cos v. It becomes 2v cos v divided by v sin v minus cos v. We will separate the variables. V sin v minus cos v divided by v cos v dv. We will keep that 2 here on the right hand side. We get 2 dx divided by x. We will integrate both the sides. To integrate the left hand side, we will split this function into 2. V sin v divided by v cos v minus cos v divided by v cos v. Equal to 2 times integral dx divided by x. The first term becomes tan v, and integral of tan v is log of absolute value of secant v, minus the second term is 1 by v, integral is log of absolute value of v, equal to 2 times log of absolute value of x. Since all these terms are having log function, we will write the constant of integration as log c. We will combine these log terms, log of secant v, we will substitute for v, v is y by x, divided by v, which is y by x. Log a minus log b is log of a divided by b. We will take this 2 as the power, so that we can combine these two log terms, log of x square c. We can cancel logarithmic function on both sides. Secant y by x divided by y by x is x square c. Let us cross multiply. Secant y by x is y by x times x square c. We can cancel x. Therefore, secant y by x is cxy. You may give this answer in terms of cos as well. Question number 8. X dy by dx minus y plus x times sine of y by x is 0. It is a function of y by x, therefore it has to be a homogeneous differential equation. We will write dy by dx, which is y minus x sine y by x divided by x. We will take this as f of x comma y. We have to show that the given differential equation is homogeneous. Let us find f of lambda x lambda y. Lambda y minus lambda x times sine of lambda y upon lambda x divided by lambda x. Lambda is common. Y minus x sine y by x divided by lambda x. We are able to cancel lambda, which is f of xy. Therefore, the given differential equation is homogeneous. Now, we will solve the differential equation. Dy by dx is y minus x sine of y by x upon x. We will substitute y by x as v, that is y is equal to vx, differentiating both sides with respect to x. Dy by dx is v plus x dv by dx equal to y is vx minus x sine vx upon x, that is v, divided by x. We will take x common. X gets cancelled. We will take v to the other side. Separating the variables, dv by sine v is equal to minus dx divided by x. We will integrate. This is integral cosecant v dv equal to minus integral dx upon x. An integral of cosecant v is log of absolute value of cosecant v minus cot v equal to minus log of absolute value of x plus log c. Let us combine these two log terms, log of absolute value of c divided by x. We will cancel the log function on both sides. We have to raise it to e, because e and log are inverse functions. They cancel each other. Cosecant v minus cot v is c by x. We will substitute for v. We get cosecant y by x minus cot y by x equal to c by x. We can give this as the answer, or we may change the trigonometric function in terms of sine and cos. 1 by sine of y by x minus cos y by x divided by sine y by x equal to c by x. We will take LCM. 1 minus cos y by x divided by sine of y by x is c divided by x. Let us cross multiply. X times 1 minus cos of y by x equal to c times sine of y by x. Question 9. Y dx plus x log of y by x dy minus 2x dy equal to 0. This is a function of y by x. We will take dy common. X log of y by x minus 2x times dy is minus y dx. Therefore, dy by dx is minus y upon x log of y by x minus 2x. We will take the negative sign to the denominator. We get 2x minus x log of y by x. We will take this as f of xy. Let us find f of lambda x lambda y, which is lambda y divided by 2 lambda x minus lambda x log of lambda y upon lambda x. Lambda is common in the denominator. We get 2x minus x log y by x, which is f of xy. Therefore, the given differential equation is homogeneous. We will solve the given equation, which is y upon 2x minus x log of y by x. It is a function of y by x. We will substitute y as vx. Therefore, dy by dx is v plus x dv by dx. We will substitute v plus x dv by dx. This is dy by dx equal to y is vx divided by 2x minus x log y by x is v. X is common in the denominator. 2 minus log v. X gets cancelled. Let us take this v term to the other side. V divided by 2 minus log v minus v. We will take LCM. 2 minus log v, v minus 2v, minus of minus plus v log v. Don't forget to distribute the negative sign, do it carefully, which becomes minus v plus v log v divided by 2 minus log v. Here v is common. We get log v minus 1 divided by 2 minus log v. We will separate the variables. 2 minus log v divided by v times log v minus 1 dv equal to dx over x. We will substitute log v minus 1 as t. Differential of log v is 1 by v dv equal to dt. Let us substitute 2 minus log v is t plus 1 from this equation divided by dv by v becomes dt and the denominator is t. Therefore, the numerator becomes 2 minus 1, which is 1, 1 minus t upon t equal to integral dx by x. We will split this into two terms, 1 by t minus 1. Now, easily we can integrate. Integral of 1 by t is log of absolute value of t and integral of 1 is t equal to log of absolute value of x plus c. We will substitute for t. T is log v minus 1. T is log v minus 1 equal to log of absolute value of x plus c. Since these terms are having log, we will write c term as log c. Log of absolute value of log y by x minus 1 equal to log xc plus log of v, which is y by x, plus 1 will become minus 1. Now, this 1 can be written as log e to the base e, so that we can combine these log terms. We get xc times y by x divided by e. Now cancelling log functions on both sides, we get log of y by x minus 1 is equal to, here x gets cancelled, we get c by e times y. Log of y by x minus 1 is, c by e is a constant. I will take it as a, where c by e is a. Question number 10. 1 plus e raised to x by y times dx plus e raised to x by y times 1 minus x by y dy is 0. Here this is a function of x by y. So, we have to write dx by dy. Let us take the second term to the other side. We will write dx by dy because it is a function of x by y. We will take this as f of xy. Let us find f of lambda x lambda y minus e raised to lambda x divided by lambda y times 1 minus lambda x divided by lambda y divided by 1 plus e power lambda x by lambda y. We are able to cancel lambda throughout, which is f of xy. Therefore, the given differential equation is homogeneous. Dx by dy is, we will distribute that negative sign, e raised to x by y, it becomes x divided by y minus 1 divided by 1 plus e raised to x by y. Since it is a function of x by y, we have to substitute x by y as v, that is x is equal to vy. Now differentiating with respect to y, we get dx by dy is equal to product rule. V into differential of y with respect to y is 1 plus y into differential of v with respect to y is dv by dy. Let us substitute v plus y dv by dy equal to e power v, x by y is v minus 1 divided by 1 plus e power v. We will take this v term to the other side and take LCM. 1 plus e power v is v e power v minus e power v minus v minus v e power v, which is minus v plus e power v divided by 1 plus e power v. We will separate the variables. Integral 1 plus e power v divided by v plus e power v dv is equal to, keeping the minus sign on the right hand side, we get integral dy by y. Now to integrate this function, we will take v plus e power v as t. Differentiating both sides, differential of v is 1, e power v dv is dt. Therefore, we get integral, the numerator becomes dt, denominator is t, minus integral dy upon y. Integral is log of absolute value of t minus log of absolute value of y plus log of absolute value of c. This can be written as log of absolute value of c divided by y. Cancelling log functions, t is c by y, and substituting for t, t is v plus e power v times y is c and v is x by y. Taking LCM, y e power x by y times y is c. Therefore, the solution is x plus y e raised to x by y equal to c. For each of the differential equations in exercises from 11 to 15, find the particular solution satisfying the given condition. Question number 11, x plus y times dy plus x minus y times dx equal to 0. This is an initial value problem. Y is 1 when x is 1. X plus y dy is equal to minus of x minus y dx. dy divided by dx is y minus x divided by x plus y, distributing the negative sign in the numerator. In this question, we need not prove that it is a homogeneous equation. So, we are not going to use that lambda method. We will directly go for the solution. Let us substitute y as Vx. Differentiating both sides with respect to x, we get dy by dx is equal to v plus x dv by dx. dy by dx is v plus x dv by dx equal to Vx minus x divided by x plus Vx. X is common. We get v minus 1 divided by x times 1 plus v. X times dv by dx is, we will take this left hand side v term to the right hand side. And the LCM is 1 plus v. V minus 1 minus v times 1 plus v. V minus 1 minus v square divided by 1 plus v, minus of v square plus 1 divided by v plus 1. Now, after this simplification, we will be able to separate the variables. V plus 1 divided by v square plus 1 dv is equal to minus dx divided by x. On the left hand side, we have linear function divided by quadratic function and there is no v term in the denominator. Directly we will separate this into two functions, v divided by v square plus 1 and 1 divided by v square plus 1. And the first integral can be done by substituting v square plus 1 as t. Differentiating both sides, 2v dv is dt. Integral v dv is dt upon 2 divided by t plus integral 1 divided by v square plus 1 dv equal to minus integral dx divided by x, half into integral of 1 by t is log of absolute value of t plus, this is tan inverse formula, tan inverse of v, and minus log of absolute value of x plus c. We will substitute for t, half log of t is v square plus 1, which is a positive value. We need not write the absolute value sign, plus tan inverse of v equal to minus log of absolute value of x plus c. Let us substitute for v. V is y by x, half log of y square divided by x square plus 1 plus tan inverse of v equal to minus log of absolute value of x plus c. We will multiply throughout by 2. Log of LCM here is x square, y square plus x square. We will bring that log term to this side, it becomes plus and we are multiplying by 2. We get 2 log of absolute value of x plus 2 tan inverse of v is y by x equal to 2 times c. We will take this 2 as the power so that we can combine these two log terms. Log of x square plus y square divided by x square times x square. plus 2 tan inverse of y by x equal to 2c. This is an initial value problem. Y is 1 when x is 1. Therefore, log of 1 square plus 1 square is 2 plus 2 tan inverse of 1 equal to 2c. Therefore, 2c is tan inverse of 1 is pi by 4. We get log 2 plus 2 times pi by 4. We will substitute the value of 2c in equation number 1 to get the particular solution. Log of x square plus y square plus 2 tan inverse of y by x equal to 2c is log 2 plus pi by 2. Question number 12. X square dy plus xy plus y square times dx equal to 0. Y is 1 when x is 1. X square dy is minus of xy plus y square dx. Therefore, dy by dx is minus of xy plus y square upon x square. We will substitute y as vx, differentiating both sides with respect to x. Dy by dx is v plus x dv by dx equal to minus of x times vx plus v square x square divided by x square. So, the equation will be only in terms of v and x now. On the right hand side, x square is common. We get v plus v square divided by x square. Therefore, x dv by dx is minus v square and minus v, which is minus v square minus 2v minus v times v plus 2. We will separate the variables. Dv upon v times v plus 2 is equal to minus dx upon x. Integrating both sides. The left hand side can be done by partial fraction method, or we can open the brackets and use completion of squares method, or we can write the numerator as v plus 2 minus v divided by v times v plus 2. If you simplify the numerator, v gets cancelled, 2 will remain. Therefore, to cancel that 2, we will write half, which is equal to minus integral dx over x, or do by partial fraction method. We can take it as a by v plus b by v plus 2. Find a and b, then integration will be easier, log of v and log of v plus 2. Now, we will separate the terms here. V plus 2 divided by v times v plus 2, which becomes 1 by v, minus v divided by v times v plus 2 becomes 1 divided by v plus 2. This comes to the same partial fraction method step. In this case, a will be half, b will be minus half. Half into integral of 1 by v is log of absolute value of v minus integral of 1 by v plus 2 is log of absolute value of v plus 2 equal to minus log of absolute value of x plus log c. We will multiply by 2 and combine these two log terms. V divided by v plus 2 equal to minus 2 times log of x plus 2 times log c. We will take these numbers as powers. We get log of c square divided by x square. We will cancel the log functions. V by v plus 2 is c square by x square. Let us substitute for v. v is y by x divided by y by x plus 2 equal to c square divided by x square. Taking LCM in the denominator, we get y plus 2x divided by x equal to c square divided by x square. We get y divided by y plus 2x equal to c square divided by x square. This is an initial value problem. Y is 1 when x is 1. Therefore, 1 divided by 1 plus 2, 3 is equal to c square divided by 1, which is c square. Therefore, c square value is 1 by 3. We will substitute c square value in equation number 1 to get the particular solution. Y divided by y plus 2x is 1 by 3 times 1 by x square. We will cross multiply. 3x square y is equal to y plus 2x. Question 13. X sine square y by x minus y times dx plus x dy equal to 0. Y is pi by 4 when x is 1. Here we have sine of y by x. It is a function of y by x. It has to be homogeneous. X dy is equal to minus of x sine square y by x minus y times dx. Therefore, dy by dx is, let us distribute the negative sign, y minus x sine square y by x divided by x. We will substitute y as vx. Therefore, dy by dx is v plus x dv by dx. Substituting for dy by dx, we get v plus x dv by dx equal to y is vx, x times sine square, vx by x becomes v divided by x. X is common in the numerator. Therefore, x times dv by dx is v minus sine square v and minus v. We will separate the variables. dv divided by sine square v is minus dx upon x. Integral cosecant square v dv is minus integral dx divided by x. An integral of cosecant square is minus cot v equal to minus log of absolute value of x minus c, so that we can cancel the negative sign throughout. We will substitute for v. v is y by x equal to log of absolute value of x plus c. This is an initial value problem. Y is pi by 4 and x is 1. Substituting these values, we get cot of pi by 4 equal to log of 1 plus c. Log 1 value is 0 and cot of pi by 4 is 1. Therefore, c is 1. Let us write the particular solution. Cot of y by x is equal to log of absolute value of x plus 1. We can write 1 as log e to the base e. We will combine these two. Log of absolute value of xe equal to cot of y by x. Question 14. dy by dx minus y by x plus cosecant y by x is 0. Y is 0 when x is 1. we will write dy by dx, and it is a homogeneous equation. Dy by dx is y by x minus cosecant y by x. We will substitute y by x as v, that is y as vx, differentiating both sides with respect to x. Substituting for dy by dx, which is v plus x dv by dx, equal to y by x is v minus cosecant v. dv upon cosecant v is equal to minus dx upon x. And 1 by cosecant is sin v. Integrating both sides, we get minus cos v is equal to minus log of absolute value of x. We will write minus c so that we can cancel negative sign throughout. Substituting for v, v is y by x equal to plus log of absolute value of x plus c. We will substitute y as 0 and x as 1. Cos of 0 by 1 is 0, log 1 plus c. Cos 0 is 1, log 1 is 0, therefore c is 1. The particular solution is cos of y by x equal to log x plus 1. And this 1 can be written as log e to the base e. The right hand side is log x plus log e, which becomes log of xe. Cos of y by x equal to log of xe. Let's do question 15. 2xy plus y square minus 2x square dy by dx is 0. Y is 2 when x is 1. 2xy plus y square is 2x square times dy by dx. Therefore, dy by dx is 2xy plus y square divided by 2x square. We will substitute y as vx. Differentiating both sides with respect to x, we get dy by dx is equal to, using product rule, we get v plus x dv by dx. dy by dx is v plus x dv by dx, and 2x, y is vx, plus v square x square divided by 2x square. X square is common, 2v plus v square upon 2x square. Therefore, x dv by dx is 2v plus v square divided by 2 minus v. LCM is 2. 2v plus v square minus 2v. We get v square divided by 2. We will separate the variables. 2 dv upon v square is equal to dx upon x. Let's integrate. 1 by v square can be written as v raised to minus 2. Integration is v raised to minus 1 divided by minus 1 equal to log of absolute value of x plus c. We will substitute for v. Minus 2 divided by v is y by x, log of absolute value of x plus c. Writing the reciprocal of y by x, we get minus 2x upon y equal to log of absolute value of x plus c. And this is an initial value problem. We will substitute y as 2 and x as 1. Minus 2 divided by 2 equal to log of 1 plus c. Log 1 is 0, therefore c value is minus 1. We will write the particular solution. Minus 2x upon y equal to log of absolute value of x minus 1. We will change the sign throughout. 2x divided by y is 1 minus log of absolute value of x. Therefore, y is 2x divided by 1 minus log of absolute value of x. Here denominator should not become 0, therefore log x should not be 1, that is x should not be e. Log e to the base e is 1. Question 16. A homogeneous differential equation of the form dx upon dy equal to h of x divided by y can be solved by making the substitution. This is a function of x by y and it is dx by dy. We have to substitute x divided by y as v. Therefore, x is vy. The correct option is C. Question 17. Which of the following is a homogeneous differential equation? Now, in option A, we have constant term 5. The degree is 0. For other terms, the degrees are 1. Not homogeneous. B subdivision, again xy degree is 2 and we have in the other term x cube and y cube of degree 3. So, not homogeneous. C subdivision, again x cube is of degree 3, y square is of degree 2, not homogeneous. Look at D option, the degrees are same. For all coefficients of dx and dy, the degree is 2. Therefore, D is the homogeneous differential equation.